DLP rules to adjust templates so that they suit your requirements, how to use a DLP feature known as document fingerprinting, and how to create custom DLP rules for scenarios that the DLP templates don't cover. First, let's go through the basics of DLP. The goal of DLP is to prevent the exposure of sensitive information, whether that be accidental or intentional, to unwanted parties. DLP uses a very sophisticated content analysis engine to examine email messages and attachments as they move through the transport pipeline. In other words, while they're in transit within your Exchange organization. DLP doesn't look at email that is already sitting in mailboxes, although as you'll see later in this module, DLP can check emails and attachments before they've been sent. The types of sensitive information that DLP is usually used to look for are things like credit card details, social security numbers, and passport numbers. Basically, all kinds of financial or personal data, especially those that are covered by various laws and privacy regulations around the world, and that probably shouldn't be sent using email, or at least not without taking steps to protect the data in the email, such as with encryption. Obviously, the consequences of accidentally emailing an Excel spreadsheet containing your customer database or credit card details to someone outside the company are potentially quite serious. A DLP policy is basically a package of transport rules that combine content analysis with various notification actions and other controls such as blocking messages. Exchange 2016 ships with about 40 DLP policy templates, and some third parties provide DLC policy templates that can be imported, or you can build your own custom DLP policies as well. The content analysis itself is quite interesting. The finer details of this aren't necessary to know for the Microsoft exam, but going through them will give you a better understanding of DLP's capabilities and how it makes decisions. To start with, DLP analyzes the content of both email messages and email attachments. So that means a credit card number can be detected whether it's written in the message itself or written in an attachment, such as a Word document or an Excel spreadsheet. Regular expressions are used to find patterns of information that could be sensitive information. A good example is a 16-digit number, which could be a credit card number. Further analysis is then performed to try and work out what that information might be. Continuing with the example of credit card numbers, a special algorithm is used to determine whether the 16-digit number matches the known patterns of credit card companies around the world, such as Visa or American Express. The content analysis then looks for further evidence, such as the word Visa or a date that could be an expiry number for the credit card, and at this point, DLP makes a decision based on the confidence that there is credit card information in the email or not. Here's a comparison of how that content analysis might treat two different emails. Both emails in this example contain names, 16-digit numbers, and dates. The regex analysis picks up on the 16-digit numbers. The numbers are analyzed using the algorithm, which incidentally is called a LUN algorithm or LUN formula, named after the IBM researcher who created it. That detail isn't important for your exam preparation, but in your spare time you might like to go online and read some more about it. The LUN algorithm will determine whether the number matches a valid credit card pattern or not. Other evidence in the email is also taken into account. On one hand, we have the keyword Visa and a date, and on the other hand, we just have a date. In the end, DLP makes a determination that it has a high enough level of confidence that the data in the first email is a credit card, as opposed to something more harmless like the second email, which has a 16-digit serial number for a product and the date the warranty for that product expires. And this is just using credit